Hey folks, glad you're here. The goal of this video is to provide you with a basic overview of VLANs, trunking, and inter VLAN routing. A packet tracer file is provided for you to follow along and practice with at your leisure. If you wish to follow along, you can pause the video here and prepare your packet tracer file. Alright, so let's get started. In this scenario, we have an office building with an east wing and a west wing. We also have a main area, an IT office, a main router, which connects the office building to the internet, which is represented through netacad.com up here. And essentially, the office has decided to expand its workforce, but they need additional address space. So the goals with this packet tracer file are to show you that these hosts down here can't currently connect. They can't talk to each other. They also cannot reach the internet at this point in time. And from there, we're going to configure the respective VLANs, configure VLAN 99 as the native VLAN, configure trunk links to carry the VLAN traffic, configure sub-interfaces on the router to route traffic between the VLANs, and finally test inter-VLAN routing and internet connectivity. So, starting with the west wing switch, we basically have to tell the switch that, hey, there's this VLAN, it's VLAN 20, and we're going to name it west wing. Alright, and from there, the hosts that are in the west wing are connected to the west wing switch on switch ports 1 and 2. So we're going to tell the switch that these two switch ports, they're access ports, and also that they belong in VLAN 20. And now we have to tell the switch that switch port 23 is a trunk. We also have to tell it that VLAN 10, 20, 30, and 99 are allowed to basically travel across that link. And we also have to tell it that VLAN 99 is the native VLAN. And at this point, we're done configuring the west wing switch. So just a little bit about native VLANs. The purpose behind a native VLAN is to tell Cisco routers and switches that traffic from these devices in the native VLAN do not have to receive an 802.1q tag in the header of the frame in order to traverse those links. And basically what this does is it allows network devices from older and previous generations that do not have the capability of adding a tag to still communicate on that network. So moving on to the east wing, we're going to tell the switch to create VLAN 30 and name it east wing. And just like with the west wing, we've got switch ports 1 and 2 connected to the two hosts within the east wing. So we're going to tell the switch to go ahead and make switch ports 1 and 2 access ports and to put them into VLAN 30. Our trunk link on the east wing switch is switch port 24, so we'll tell the switch to turn it into a trunk, allow VLANs 10, 20, 30, and 99, and make the native VLAN 99. And at this point, we're done configuring the east wing switch. So let's move on to the main office switch. Now, this one's going to be a little bit different because essentially this switch is managing our connection to the router. So it's managing all of the VLANs connections to the router. And because of that, it needs to know about all of them. So we're going to go ahead and tell the main office switch to create VLAN 10, 20, 30, and 99 and name them their respective names. Alright, and just like East Wing and West Wing, we have switch ports 1 and 2 in the main office connected to the two hosts within the main office. So we will tell the switch that those two switch ports are access ports and they belong in VLAN 10. And for the IT office, that one is switch port 22, so we will just repeat the process there. Switch port 22 should be access, should also be in VLAN 99. Now we're going to tell this switch about our trunk links, and we have 3 of them. We have switch port 23, switch port 24, and G01. All of these interfaces need to be configured as trunks. Tell it to allow VLAN 10, 20, 30, 99, and that the native VLAN is 99. And at this point, we have finished configuring our main office switch. We're going to go ahead and configure our router. So this particular type of configuration is called router on a stick, and it's called that because there's only one connection to the router, one physical connection that allows all of the VLANs to communicate with each other. Alright, so in order to configure routing in between the VLANs, we're going to configure something called a sub interface. Essentially, you just add a dot, whatever number that you want, after the interface itself. And you can see you're in the sub interface menu. And before you can assign an IP address to that sub interface, you need to tell the router to encapsulate the traffic with a .1q tag, and you also need to specify which number belongs in that tag. For VLAN 10, we're going to go ahead and tell it to encapsulate with .1q 10, and then we'll give it IP address 192.168.10.1 as the default gateway for VLAN 10. And you actually don't have to tell it to bring the sub interface up, but it's something that I like to do just out of habit. And for the rest of these sub interfaces, for the sake of time, I'm just going to copy the rest of this. And we're going to create sub interface G01.20.30.99 and tell it what respective .1q tag number to place and assign the IP addresses. Now, as far as the native VLAN 99, in order to specify that to the router, you simply say native after the tag, the number of the .1q tag. Just tell it native. Alright, so now in order to bring these interfaces online, you go back to the root interface, not the sub interfaces, the original interface G01, and just, like usual, just bring it up. And at this point, we should have successfully configured the router. We should have created all of our VLANs, all of our trunk links, and should have enabled inter VLAN routing as well as access to the internet. So let's go ahead and test our connectivity. I'm going to fast forward to bring that interface fully up. All right, and from the IT terminal, let's ping 192.168. Let's just go down the line. 10.10. All right, we're connected there. 20.10. And 30.10. All right, fantastic. Now let's see if we have internet connectivity and we can reach netacad.com. It's going to take a moment. But ultimately it should load, and then you'll know for sure that you have full connectivity. And there we go. All right, so thank you very much for your time. I hope you found this video tutorial to be helpful to you. Thank you for watching, and I hope you have a great day.